A very good evening to Dr. Kok and also Dr. Ng. So today, I am going to present the coursework of Basic Algebra, MTES1074, which is the topic of linear programming. So before we going through the discussion, let me introduce myself first. My name is Fazira Natasha binti Kafar. So what I'm going to discuss in this presentation today is 1.0, the introduction, 2.0, the application of algebra in daily life, 3.0, the model of linear programming, 4.0, the solving of a linear programming problem, and last one is 5.0, the conclusion. So the first one is the introduction. Linear programming, or we can call it as LP, is a simple method that uses a linear function to describe complicated real-world relationship. It is a branch or subset of mathematical programming. LP is the quantitative analysis technique for deciding to achieve the desired goal. It is a simple optimization technique. So the methods of linear programming were originally developed between 1945 and 1955 by American mathematicians to solve problems arising in industry and economic planning. So this is the history of the linear programming methods. So the problems that will be solved usually have two variables in them, which is we are going to discuss more in the next slide, and can be solved graphically. This linear programming method is concerned with the maximization or minimization of a linear objective function that we are going to discuss more detail on in the next slide, subject to linear inequality and inequality constraints. So the example is one of the importance of linear programming in business is to maximize profit or minimize the cost. According to Igbnihe ETAL 2015, applied linear programming model to maximize profit in a local soap production company. The company produced three different types of soap, 5-gram white soap, two different types of soap, 5-gram white soap and 2 10-gram white soap. From the data analysis, it was observed that the company spends more on color soap and they get white soap than color soap. Thus, the company was advised to produce more of white soap than the color soap in order to obtain an optimal profit, which is the maximized profit. So let me go through the 2.0, the application of algebra in daily life. Before we going more to the linear programming problems, let us appreciate the algebra in our daily life. So basically, algebra has many benefits for us in our daily life. So the applications in daily life, for example, solving the quantities of something such as the quantities of each type of fruits and what are the sum of the quantities. By applying the concept of algebra, it makes us easier to calculate the problem in a very easy and efficient way. What is the application of algebra in daily life in geometry? So, in geometry, it is through the use of equations in graph. We can plot a set of points x and y, the y-axis and also x-axis, according to an equation. It can be used to find the area of any two-dimensional shapes. We use their specific area formula. We have to substitute the corresponding dimensions into the area formula and solve for the area. For instance, the area of triangle is equal to 1/2 times the base and also the height. Next is the application of algebra in computer programming. So basically, algebra is used in computer programming to develop algorithms and software for working with math functions. Programming is more than just coding, it is about solving problems. So basically, these are the few things that the application of algebra in our daily life. Okay, so the next one is the model 3.0, the model of linear programming. So there are three important things that we need to know, we need to find before we're going to solve the linear programming problems. So the first one is the decision variables, the second one is the objective function, and the third one is the constraint. So the first one here is the decision variables. What it is? It is the physical quantities used to be calculated and controlled by the decision maker and represented by mathematical symbols. For example, in the company, there are two types of shirt, which is the green shirt and also the blue shirt. So we need to find how many shirt of blue and green need to produce by the company. So instead of we use the sentence is a long sentence, we just define the variables by using x, y. For example, like x is for the green shirt, how many green shirt the company needs to produce, and y is how many the blue shirt company needs to produce. So basically we can usually denote them by x and also y. It usually denoted it says here, like I said before, it is usually denoted by x1, x2, and so on, xn, where n is a finite positive integer. So all decision variables are continuous, controllable, and non-negative. So basically it is not something that negative number. It is must a positive number. So the second important things we need to know before we're going to solve the linear programming problems is that the objective function. So the objective function is prominently used to represent and solve the optimization problems of LP. For example, like the maximize and the minimization problems of LP. So the objective function in linear programming problem is expressed in terms of the decision variables. So it is berkait dengan the decision variables. So the goal of the linear programming problem will inform you whether you need to maximize or minimize the objective function. So it generally tends to represent cost or profit. On the previous example that I've been discussed, it is generally tends to represent cost or profit. So the third important things that we need to know before solving the linear programming problems is that the constraints. So the constraints are the restriction or limitations on the decision variables. So yeah, it is the limitation. So the constraints have to be expressed as linear inequalities or inequalities in terms of decision variables. So basically decision variables, we need to decide, we need to define something that we need to solve. We are going to go on details on the problems. For example, machine time, investment capital, labor time, and supervision time can be the limitation, or we name it as constraint. So the fourth one is solving a linear programming problem. So the problem that I have come out with, and I have asked the lecturer, the Dr. Koch, and it is acceptable for this problem for solving a linear programming. So let me read the question. A calculator company produced two types of calculators, which are scientific calculators and graphing calculators. Both calculators produce in the same time. The scientific calculators are sold for 100 ringgit and the graphing calculators are sold for 80 ringgit. The company wants to make at least 20 calculators each week. The calculators making process uses two machines, which is alpha machine and beta machine. Each machine can be run at most 80 hours a week. Scientific calculator requires 2 hours of processing time on alpha machine and 4 hours of processing time on beta machine, while the graphing calculators requires 4 hours of processing time on alpha machine and 2 hours of processing time on beta machine. Thus, how many of each models of calculators should the company make to maximize its sales? So it is basically a long question, right? So how we are going to solve this linear programming problem? There are steps. So the first step is we need to read the problem carefully. So this problem I have highlighted the sentence that we need to focus more. The first one is the scientific calculators are sold for 100 ringgit and the graphing calculators are sold for 80 ringgit. The company wants to make at least 20 calculators each week. So this is our focus right now. At least 20 calculators each week. The calculators making process uses two machines, which is alpha machine and beta machine. So when we talk about machine, basically it is the limitation, the constraint. Each machine can be run for at most 80 hours a week. So both machine can be run for at most 80 hours. So it cannot be greater than 80 hours. It must be less than 80 hours or equals to 80 hours. So the third focus here is the scientific calculator requires 2 hours of processing time on alpha machine and 4 hours processing time on beta machine, while the graphing calculator requires 4 hours of processing time on alpha machine and 2 hours of processing time on beta machine. So this is the other things that we need to highlight and focus on this question. So this is what is the question 1. This is our desired goal. Thus, how many of each models of calculator should the company make to maximize itself? So the words maximize here is actually the objective function, the things that we need to find, our desired goal. So it is basically how many of each models of calculator should the company make to maximize itself. So finish with the reading the problems carefully. So the first step to solve this problem, the previous problem, is identify the decision variables. As we can see the previous slide before, it says that the company wants to produce two types of calculator, which is the graphing calculators and also the scientific calculators. So the first step, we need to define the variables using the symbols x and y. As I said before, it is a long sentence, so we cannot in order to make it easier for us, we just define the long sentence with some variables, for example like xy, x1, x2. Okay, so in this case, I have defined the variables using the symbols of x and y. I've defined x equals to the number of scientific calculator, while I define y as the number of graphing calculator. So it will make us easier to solving this linear programming problems. So the second step is we identify the objective function. Based from the previous problem, it says that how many of each models of calculator should the company make to maximize itself. So our objective function here is maximize. The keyword is to maximize the company profit. Hence, in this case, our goal is to find the maximum number of each models of calculator should the company make. Then we express the objective function in terms of the variables that we have defined above, that we have defined here, x and y, as maximize z equals to 100x and plus 80y. Why it is 100x? Because on the previous problem, it says that the scientific calculators, which is x that we have defined, are sold for 100 ringgit, and the graphing calculator, which is we define as y, are sold for 80 ringgit. So our objective function is maximize z equals to 100x plus 80y. Finish with the objective function and also the decision variables. The third one is we identify the constraints. So the steps are, firstly, we transform the constraint from the long sentence into the form of linear inequalities. Then, we solve the linear inequalities using preferable algebra techniques, and after that, we determine the x-intercept and y-intercepts for each of the linear inequalities in order to make the graph. So the first constraint is coming from the company wants to make at least 20 calculators each week for both calculator. So in this sentence, we can conclude that x plus y is greater or equal to 20, which is the graphing calculators plus the scientific calculators is equal or more to 20. So in order to make the graph, you need to find the x-intercept and y-intercept, right? So we divide the whole inequality by 20 and all answers are in the intercept form. So we conclude that x-intercept is equals to 20 and the y-intercept is equals to 20 for the first constraint that we have, that coming from the company wants to make at least 20 calculators each week. What is the second constraint? From the previous problem, we divide into two parts. It says that alpha, the second cases is the machine, right? The limitation. So from the previous problem, we divide it into two parts, which is for alpha machine and also beta machine for both calculator, for alpha machine for the graphing calculators and scientific calculators, and beta machine for graphing calculators and scientific calculators. So the second sentence is that each machine can be run at most 80 hours a week. So basically it is for both machine to run can be run at most 80 hours a week. For alpha machine, scientific calculator requires 2 hours of processing time on alpha machine, and graphing calculators requires 4 hours of processing time on alpha machine. So we divided into two parts for alpha machine 1 and the beta machine 1. So for alpha machine here, it says that scientific calculator requires 2 hours and graphing calculators requires 4 hours. Can be run at most 80 hours per week, 80 hours a week. So in this case, our constraint is 2x, which is x is for scientific, y plus for y, which is y is for graphing calculators, must be less or equals to 80. So we divided the whole inequality by 80 and we got the x-intercept equals to 40 and y-intercept equals to 20 for the second constraint. That is for the second constraint. So the third constraint is coming from the beta machine. It says here that scientific calculator requires 4 hours of processing time, while the graphing calculators requires of 2 hours of processing time. So we need to transform this sentence to algebra equation so that we can solve the linear programming problems. So in this case, we says that for x, which is x is equals to scientific calculators, plus 2y must be less or equal to 80. So we divide the whole inequality by 80, so it equals to 1 to find the x-intercept and y-intercept. So our x-intercept for the third constraint equals to 20, while our y-intercepts for the third constraint is equal to 40. Okay. The fourth constraint is applied to all linear programming problem, which is x must be greater or equal to 0, and y must be greater or equal to 0. So basically the decision variables that we have been said before, it cannot be negative number. It must be continuous and non-negative. So that is the steps how to find the constraint. So basically we have identified the decision variables, we have identified the objective function, and also we have identified the constraint we have. So move to the 4.4. We solve the two variable linear programming model. When we talk about linear programming model, it must have a graph, so it's easier for us to find maximize profit or minimize cost. So in this case, it says that we need to find maximize, right? How to maximize the cells. So we use the graphical method. So we plot and draw all the linear inequalities, which is constraints, on one grid. we have find the x-intercept, we have find the y-intercepts, right? So the first one here is 4x plus 2y must be less or equal to 80. The x-intercept is 20 while y-intercept is 40. So we plot the graph and then we draw the line. The second one is x plus y equals or greater or equals to 20. The x-intercept is 20 while the y-intercept is 20, and then we plot the graph and then we draw the line. The third one is the 2x plus y less or equal to 80. We plot the graph and we draw the line. After that, we solve the objective function and draw the isoprofit line. So the objective function that we discussed previously is maximize z equals to 100x plus 80y. So that is our objective function. So we substitute z with any positive value. It must be a positive value, it cannot be a negative value. And make it easier for us, we substitute the value of 20. So we come to a conclusion that the x-intercept is equals to 5 while the y-intercept equals to 4. As you can see here, I have plotted the point x-intercept 5, y-intercept 4, and then this is the isoprofit line, and then we push the isoprofit line into the region, the most maximum region. And then we determine the maximum point by pushing the, as I said before, by pushing the isoprofit line in a parallel way. So it must be in a parallel way until it touches the furthest point in the region. So in here, the maximum point is equals to 13.4. The x-axis is 13.4 and the y-axis is 13.2. So as we have defined the decision variables, x equals to how many scientific calculator the company needs to produce, and y-axis here is 13.2 is how many the graphing calculators the company needs to produce. And then we have solved the graph. So based on the graph above, we can conclude that the maximum point is 13.4, 13.2. Then we substitute the coordinate of the maximum point into the objective function to get the final answer of the problem. So we have substitute the value, and the maximize is z equals to 2,396. So to conclude, the company should have 13 models for each type of the calculators. So basically, scientific calculators must have 13 models, and also the graphing calculators must have 13 models to maximize their income. So to conclude, the maximum income for their company is 2,396 ringgit. So basically, it is the maximum income. So in this case, we have finally solved the linear programming problems here. Yay! So lastly is the conclusion. From this project, we came to a conclusion that in linear programming, we formulate our real-life problem into a mathematical model. So from the previous problem, it is about the company wants to make how many calculators for both calculators need to produce to maximize itself. So basically, it is the problem that we need to solve by using linear programming. So it involves an objective function and linear inequalities which subject to constraint the limitation. It is a problem that is concerned with finding the optimal value of the given linear function. The optimal value can be either maximum value or a minimum value. Linear programming is not just a technique, but it is a planning process of determining a particular plan of action from among several alternatives. It is widely used in many industries, management science, engineering, and commerce. Thus, it is important for us as a mathematics student to learn linear programming, as it is not just how we answer the problem in the examination, but it is something that usually always related with our daily life, so that we can solve our difficult tasks much easier. So I think that is from me now. Yeah, I think that is all for now. Thank you and goodbye.